Today we're talking about a blast furnace. Now, if you're doing your product technology or your steel manufacturing courses, whether that be your CSWIp or PCN NDE welding inspection, you'll be expected to know at least something about blast furnaces. So looking at the history first, they go back as China as far back as 2000 BC. They first appeared in Europe in around 1200s, so the 13th century. But back at this point, we were using charcoal instead of coal. Coal and charcoal produce quite a lot of sulfur, and that then in turn produces very brittle iron. So the iron is all right, but it's not amazing for many things, especially for engineering. And it was holding us back for a long time in how to use iron to be able to be strong enough to make pressure vessels and bridges and the likes. So that's where a man called Abraham Darby came along. And in 1709, he worked out how to use coke as a fuel. And this changed the way iron is produced and started to make engineering grade, if that's a good term for it, iron, which allowed the manufacture of structures in a much better way. 70 years after Abraham the First worked out how to do this, Abraham Darby the Third, under the design of Thomas Pritchard, designed and built the iron bridge, which still stands today in the UK. It's made from about 378 tons of cast iron, and it cost around £6,000. Now, doing a quick calculation on an online conversion chart here, that's about £1.1 million today. So, it's not a huge bridge. It's still quite costly. So looking at how the blast furnace works, well, what we have is a blast furnace. Normally it's a structure which is lined with refractory bricks to contain the heat. We fill that furnace with a mixture of coke, limestone and iron ore in these layers. And as the layers move down into the heat, into the melting part of the furnace, which normally takes around 8 hours or so, we get a chemical change in the iron ore, and it reduces to take out the oxygen and only leave molten iron or molten steel. That sits in the middle, but as that's happening, we get gas extraction. So large amounts of fumes are coming off the top of the blast furnace, and those gases are captured and then go through a dust cyclone. So that takes out any heavy or solid particles from the gas. We then pass that through a series of towers, which then the air is blasted back into the furnace to keep everything hot and maintain that reaction going. Now, that whole part of it there, I'm showing as a very simple sort of one tower and away we go. It's its own process. It's a process there, but we're not going to go into that today. And out the back end of that, we take it to a chimney, and that's the waste. Now, once we've separated it into two parts, we have a slag layer and a molten pig iron layer. So we're going to take those out into torpedo tubes or into ladles or the likes. So we pull the slag off into one, and that's going to go for waste. It goes into slag heaps, can be used for lots of other things in manufacturing, but it's, as far as we're concerned here, it's waste. And then we fill the other torpedo tube up with our molten pig iron, and that's going to go on to another process. And that's pulled down these channels as molten iron, and it's still at this point not very good. Pig iron is still fairly brittle in itself, and we're going to need to do something additional to that. So once we've pulled the pig iron off, We're going to take these away, the slag as waste and the iron down, and that's going to go to our secondary process, which is our basic oxygen steel system, our BOSS system. And that is going to help change that pig iron, reduce the oxygen and the carbon content even further, so that we get to more what we need it to be usable for engineering. But as a very quick 5-minute, there's blast furnace and how it works, and that should get you pretty much into your course material fairly easily. So as normal, please stay safe and good luck with your studies.